That's not right. Except don't ignore that. That's not what we're doing. We're doing linear inequalities in two variables. And by linear inequalities, we mean it's linear because x and y are to the first power. That's how you know an equation is linear, right? It's two variables, obviously, x and y, and it's an inequality because we don't have an equal sign. That would make it an equation. We have one of these symbols, right? And we've been using these symbols some already. So less than or equal to, greater than or equal to. Good. Patrick, Alyssa, you good? Good. Okay. So we're going to compare now what it is to graph an equation, which we've already been doing, and what it is to graph an inequality, right? Remember, this is what we call the standard form. We did that in the quiz we just did, right? How would I graph this line? I would cover up the y, solve for x. 2 times 3 equals 6. Then I would cover up the x, solve for y. Negative 3 times negative 2 is y. There's my x-intercept and my y-intercept. Connect them with a line. Okay. Now, the difference here is now we're doing greater than or less than or equal to, not an equal sign. We're still going to have that line is on the graph, but half of the plane is going to be shaded now, which means that it's not just the points on this line that are going to solve that inequality. It's also going to be either one side or the other side. So it looks like when you solve an inequality or you graph an inequality, it looks something like this. I think I've got this set up. Right, let's see. Usually you have to draw your line and then you have to shade one side or the other. So what we're going to do is we just figure out how do you decide where you're going to shade. Yeah.
Doesn't matter which side that you shade in.
Yes, that's going to be almost the whole point of what we're doing. How do you figure out which side to shade, right? And then there's a little bit of a difference in how do you draw the line. We know where to draw the line. That's what we learned before. But there's difference in the inequality symbol, how you draw it. Are we ready to go? So notice the difference. I'll do the shading in a minute, but notice the difference in the lines that I've drawn. This is comparing less than to less than or equal to. And what do you see in the graph of the line? One of them is dashed and the other one is solid. It's kind of like when you graph an inequality on a number line, sometimes you use open circle and sometimes you use closed. This is like the open circle. It means the points on this line actually do not solve that equation, right? When you have or equal to, that means the points on that line do solve the equation. So we're going to have to draw the line and then decide based on whether it's or equal to or not, whether you use a dashed line or a solid line. So the shading, and I'm just going to shade it in the same place it is the right side, right? Shaded, shaded, something like that. So these are the steps to graph a linear inequality in two variables. First, we are going to graph the boundary line, right? What's in the middle? We're going to use the dashed line for less than or greater than, a solid line for less than or equal to or greater than or equal to. Okay, then we've got to decide which side of that line should we shade. And generally, the way we do that is we test a point. I mean, we go to one side of the line or the other. Just take a point. Everybody in here could take a different point. Plug it into the inequalities. See whether it leads to a true statement. If it does, shade that side of the line. If it leads to a false statement, shade the other side of the line. For example, when we were doing the previous, in my mind, what I was thinking is, I know that the line goes here. I tested a point in my head. Now, normally, if 0, 0 is not on the line, that's a great point to use because the calculation is pretty easy when you plug in 0, right? So if I test 0, 0 here, I'm going to get 0 minus 0 is less than 6. 0 is less than 6. Is that true? Yeah, so that's why I shaded here, right? If I tested a point down here, let's say I test 1, 2, 3, 4, 5, 0, 5, right? Is that right? No, 0, negative 5, sorry. Then I would have negative 3 times negative 5 is positive 15. Is positive 15 less than 6? No. So you wouldn't shade. You would say, okay, that means don't shade the side that had that point. Shade the opposite side. So you're choose the test point which is not on the line, and you could choose anything you think makes the calculation easier. If it doesn't go through the origin, that's probably the easiest one to use. That's the one I would use. So before we start the graphing of it, we need to just practice plugging in a point and seeing whether it's a solution or not. Right, here's 4 possibilities. It's saying one of those is not a solution. So plug it in and see which one of those would not be a solution of the inequality. Right, don't stare off into space, start plugging them in, right? There's an equation. There's some points. Plug it in, see what you get. Which one of those does not satisfy the inequality? Does number 1 solve it? Does 0, 0? If I say 0 minus 0 is less than or equal to 6, is that true? Yeah, that's good. How about 6 minus, stop that. Edit, undo, go back. 6 minus 3 times negative 1 is less than or equal to 6. Is that true? That's 6 plus 3, less than or equal to 6. Is that true? No, that's not true. So that is not a solution. B is not a solution. Okay. So when we tested equations, we had to have equals on one side, right? Equals, one thing equals the other. Now it's going to be a less than or a greater than. Let's try, I think the next is the you try. Okay. Tell whether each one of those points is a solution of the given inequality. Was number 1 a solution? 0 plus 0 is less than 8. That is a yes. How about number 2? What did you get when you plugged in 0, 4? 8 is less than 8. That's not true. That's a no. What did you get when you plugged in 3 and 5 for x and y? Yeah, you got 7 is less than 8, and that's a yes. Okay, so that's what we mean by testing a point. But you'll get to pick the point. You could pick any point that's not on the line. So graph the inequality. So these are the steps. These are pretty much the steps that they told us on that slide. First, graph the equation y equals 4x minus 3, right? That's why we practice graphing slope-intercept form, although we could do it in other forms, right? So how do I graph this line? What's the first point? The y-intercept is negative 3, and then how do I use 4 to find another point on the line? Up 4, right 1. Okay. Now before I draw the line, I've got to decide, should I use a solid or a dashed line? Right? It's a greater than. Should I use solid or dashed? If that's a dash. So let me pick my line. And I think I've got a dashed on there. And is it blue? Yes. So it should look something like this. Okay. So there's my line. That was step 1. Step 2. Test a point. So what point do we want to test? Yeah, I mean, I'm going to change this to red just because I can. Right, let's take our test point right there. Right, that is the test point of 0, 0. Okay, plug that in. 0 equals 4 times 0 minus 3. 0 equals negative 3. Oh, sorry, that was wrong. What did I do wrong? I didn't plug it into the inequality. I plugged it into the equation. Remember, I've got to plug it into that. 0 is greater than 4 times 0 minus 3. 0 is greater than negative 3. Is that true? Yeah, that is true. So that means I should shade on the side which has that point. So shade. Okay, how about this one? Graph the line x plus 2y equals 0. Okay, now that's not in slope-intercept form. So will it work? Will it work for me to find the x and the y-intercept on this one? I mean, if I plug in the y is 0, then I get x equals, and if I plug in x equals 0, then I get y equals. So actually, what is the x and the y-intercept? It's just the origin. So it's only one point. So this is the one time when graphing by using intercepts isn't going to work because we need 2 points. So let's solve it for y and graph it as slope-intercept. Right? This will be 2y equals negative x. Y equals negative 1/2 x. Okay, so what is the y-intercept? 0. What is the slope telling me to do? Down 1, right 2. Should I use a solid or a dashed line? It looks like it's solid. So let me go back here and make that a solid. And look something like that. As longer as it needs to be. Okay, now we need a test point. Would it be a good test point? Could I use 0, 0 again? Why can't I use 0, 0? It's on the line. You know, we need to know which side of the line to do. So what's another point that might be easy to check? 0, 1. Okay, so that's actually pretty good. Actually. Not that I don't expect that from Ramir every time. 0, 1. So we're going to use 0, 1. Okay, plug that in here. 0 plus 2 times 1 is less than or equal to 0. That tells you that 2 is less than or equal to 0. Is that true? That's not true. What does that tell you about where you should shade? Yeah, not the side that had the test point, because it failed the test. Shade on the other side. right? So first you graph the line, then you test a point, and then you decide whether the line is solid or dashed. Then you test a point and shade accordingly, right? So you guys try that one. So how did you graph the line? Did you solve it for y? Or did you use standard form and just find the intercepts? I mean, what is the x-intercept? -1, right? So actually finding the intercepts is pretty easy here, right? The x-intercept is -1. The y-intercept is -1/3, right? You'd have to divide by 3. And those are fine. Let's use that. That is the blue. So the x-intercept was -1. That's here. The y-intercept was -1/3, which is here. They're kind of close, but hey, it's 2 points. So am I going to use a solid or a dashed line for that? Right? That means solid right there. So let me do something like this. I didn't change my color, so that's wrong. Okay, now need to test a point. Which is a good test point? 0, 0? Sure, it's not on the line, so let's use that. I'm just going to use blue to highlight that. The test point is right there. 0, 0. Okay, 0 plus 3 times 0 is greater than or equal to -1. 0 is greater than or equal to -1. Is that true? So what does that tell me to do? True. Shade on the side which has that dot. Now, there is another way to determine that, which will not require that you need a test point, right? And that is, if I go back, and the book didn't actually have this, that's why I didn't think of it before. Okay, let's say I'm doing this one here. This one is in slope-intercept form. When you solve for y in your inequality right there, then that's telling you which side of the line to shade. Since it's y is greater, then you shade above the line. If it was y less, then you would shade below the line. You wouldn't need to find a test point. You know, if you're dealing with, let's say, one like this, I mean, here we solved this one for y. So if I solve that, it would have been y is less than or equal to -1/2 x. So it would have been shaded below because it's y less than shade below. So you can always just solve these, solve your inequality for y, and then that will tell you directly shade above, shade below. Okay, let's try. So now these last couple are, it says linear inequalities in 2 variables, but that's not 2 variables. What does that tell you about the line that we have to graph that's dividing the plane into 2 parts? What line are we going to graph? Y equals -3. What kind of line? It's a horizontal line. Okay. So even though it says 2 variables, it's actually only 1 variable there. But you're graphing in the coordinate plane. So otherwise you might think, well, this could be a number line. I mean, if it's only got y greater than or equal to -3, you could have made a number line and put a -3 on it and shade to one side. But we know we're graphing in the plane on a flat surface, x and y axes. So first we're going to graph the line y equals -3. Okay, that will be there. Should I make it solid or dashed? Yeah, because of that right there, that's going to be solid. Okay, now we're going to test a point. If you need to. I mean, if it says that y, oh, I did it in the wrong direction, didn't you? You're probably sitting there going, he's stupid. That's right. Let me see if I can make this. Just get rid of it. Oh, there we go. Okay, there is y equals -3. Now, if it says greater than, where do you think we're going to shade? Above or below that line? It's going to be above. I mean, it should be pretty clear. If you have a horizontal line dividing, greater than means above, less than means below. If you tested a point, let's say I tested 0, 0, right? Well, I don't have an x to plug into, just plug in the y. Is 0 greater than or equal to -3? Yeah, so shade above the line. One way or the other. Shade above the line. Okay, how about x less than -1? We have to graph the line x equals -1. What kind of a line is it? It's vertical. Okay, do you think I would be shading to the left or to the right if it's x less than -1? Chase? Should I go to the left or go to the right? Go to the left. I mean, an x-axis, less than means to the left. Now, you could test a point. What if you tested 0, 0? Is 0 less than -1? No. So don't shade where that point came from. Shade the other side. So, oops. Okay. So those are kind of special cases, right? When you have horizontal or vertical lines. All right, do the number 5, y greater than 1. Okay, so we have to graph the line y equals 1, right? Y equals 1 is a horizontal line. Should it be solid or dashed? It should have been dashed because it's not or equal to. So it should have been like that. And then which side would you shade if it's greater than that line? Above. Okay, do the second one. Y less than or equal to 3. So we're going to graph the line y equals 3, which is a horizontal line. Should it be solid or dashed? Solid. So I come over here and make it a solid. And then should it be shaded above or below, considering its y is less than? Should be below. Okay, and try the next one. X is less than -2. First, quiet please, let's go. Let's finish. Graph the line x equals -2. What kind of a line is it? Vertical. Is it solid or dashed? Dashed because it's not or equal to. So I need the dashed line. -2 is here. And then on the x-axis, where do I go for less? To the left. So we get it? Okay. Then let's be done. Why is it what?